Welcome to the last video of Chapter 1. Woo! It's going to be finding perimeter, circumference, and area. You can probably guess at our objective. We're going to calculate the perimeter, circumference, and area of polygons. So we're going to focus on four main shapes here. So we're going to look at the table. You're going to notice the left-hand column has the shape. The next column, we're going to draw a figure. And then we're going to write down the formulas for the perimeter and the area of each of these shapes. Now you will need to memorize these formulas, but most of them you should already know. Okay, rectangle. You guys should be able to draw a rectangle yourself. What's important about a rectangle is it has four right angles, and the opposite sides are congruent. So once we get to semester 2, we're going to learn all about rectangles and all their important properties. But for right now, that's all you really need to know. Opposite sides are congruent, and it has four right angles. Now to find the perimeter, you just add up the sides. Pretty easy. Area of a rectangle is going to be base times height or length times width. Either one. Square is just a really special type of rectangle. A square has all the sides are congruent. And then it also has four right angles. Okay, all the sides congruent, all the angles are congruent. A square is really just a regular quadrilateral. You don't need to know that, but it's fun. So for a square, for the perimeter, again, you just add up the sides. For area of a square, you can do base times height, you can do length times width. But what's important is the base and the height are the same in a square. The length and the width are the same. So it really ends up just being one of the sides squared. Triangle. Find the perimeter, you got it, add up the sides. So perimeter, you should remember, is just the distance around a figure, whereas area is all the stuff inside of it also. So the area of a triangle, this one is more interesting also, is going to be 1/2 base times height. Okay, circle is where it gets a little more interesting. So we're going to learn about circles a little bit more in second semester, and then next year you'll learn more about circles. But what defines a circle is its center and then the distance from the center to the outside. Hopefully you guys remember that that's called a radius. Now to find the perimeter of a circle, well, we don't have any sides to add up. So instead of using the word perimeter, we use the word circumference. So if I asked you to find the circumference of a circle, it's just like the perimeter. The circumference is 2 pi r. Area of a circle is still called area. The area of a circle is pi r squared. So my guess is that this is maybe where you need to do a little bit of memorizing. In terms of those formulas, I would bet rectangle and square, you know how to find the perimeter and the area. But you will need to know how to find the perimeter and area of both triangles and circles as well. Okay, let's move on to our first real example where we're doing something a little bit more exciting. So example number 1, it says triangle QRS has vertices Q, R, and S. What is the approximate perimeter? So first thing that I'm going to do is draw myself a figure. Can't really do a whole lot if I can't visualize this. Okay, so Q is at 1, 2. R is at 4, 6. And S is at 5, 2. Okay, so we're asked to find the approximate perimeter. Now to calculate the perimeter of a figure, we just add up the sides. The issue here is we don't know any of the sides. All we have is this graph. So I need to think, how am I going to find each of those sides? Well, you're going to have to use the distance formula. You need to find 3 sides, so you're going to have to do the distance formula 3 times. I'm going to move this down a little bit. I'm going to start the distance formula with QR. So I'm going to start by subtracting those x's, and then I'm going to have to subtract those y's and square them. 1 subtract 4 is going to be negative 3 squared. 2 subtract 6 is going to be negative 4 squared. Negative 3 squared is 9. Negative 4 squared is 16. This ends up being the square root of 25, which is just 5. So I get QR to be 5. I'm also going to have to do RS. Same thing, subtract my x's, so I have 4 subtract 5. I have 6 subtract 2. 4 subtract 5 is going to give me negative 1 squared. 6 subtract 4 is going to give me, 6 subtract 2 is going to give me 4 squared. So this is going to be the square root of 1 add 16. So RS is going to be the square root of 17. Okay, that was 2 sides, so you're left to do the 3rd side on your own. Right now, pause the video and find QS, please. Okay, I'm not going to show you the work, but I am going to tell you that you should have gotten QS to be 4. So if you didn't, you made a mistake. If you made a mistake, that's okay, but I want you to fix it. So if you made a mistake and you didn't get 4, pause the video right now and go back and find your mistake. If not, we're going to keep going. Now it says, what is the approximate perimeter? So we still have to answer the question. So in order to find the perimeter, we have to add up the sides. So I have my side of 5, I have my side of root 17, and I have my side of 4. Now, 5 and 4 are like terms, so that becomes 9 plus root 17. Root 17 is not a like term, so do not add it with the 9. Now, in my calculator, I can get a decimal approximation of this, so I know a little bit more clearly what it's like. Decimal approximation of this is 8.12. units. So my perimeter is 9 add root 17, which is about 8.12 units. If you gave your answer as 8.12 in class, I would accept that. Okay, so that was a review of the distance formula. Now we're going to look at example number 2. It says the circumference of a circle is 24. Find the area. So circumference is 24. I want to find the area. Okay, so what we know about circumference so far is that it's 2 pi r, and we know that area is pi r squared. So what do those two have in common? Well, hopefully it's jumping out at you that they have the radius in common. Okay, so I'm going to need to find the radius and then use it to find the area. So my circumference is 2 pi r, but I'm told that the circumference is 24. So 24 equals 2 pi r, and I need to solve for the radius. I'm going to divide both sides by 2. 24 divided by 2 is going to give me 12. My 2's cancel, so 12 equals pi r. I'm interested in the radius, not the pi, so I'm going to have to divide by pi. Now you can do this in your calculator. Do 12 divided by pi, and it's going to give you a decimal, which is okay. Use that decimal. When I did 12 divided by pi in my calculator, I got 3.8197. Now you do have a pi button on the calculator, so look around for it. It's going to be second, and then that button under clear. I will show you that again in class tomorrow, just remind me. Now that I have the radius, I can find the area. So my area is pi times my radius squared. So pi times 3.8197 squared. By order of operations, make sure that you do the squaring first, and then you multiply by pi. When I do that, I get the area to be about 45.837 centimeters squared. Remember that area is always units squared. Okay, when you come to class tomorrow, we'll do some more with that pi button. So if you're not using the pi button yet and you're just using 3.14, that's fine. Let's flip to the next page and do a few more examples. Okay, so example 3, it says the area of a rectangle is 18. The length of the rectangle is twice its width. Find the dimensions. So I'm going to do example 3 with you, and you're going to do example 4 on your own. So I'm a visual learner, so I need a picture. So I'm going to start example 3 by drawing myself a picture. So I have a rectangle, the area is 18. It says the length is twice the width. The length is twice the width. So which one is longer? The length is twice the width. That means the length is going to be bigger. So I'm going to mark my width, W. My length is twice that. So my length is twice the width, is 2W. And then it says find the dimensions. Well, hopefully you remember that the area of a rectangle is length times width. My area is 18. Instead of writing L for length, I'm going to write twice the width. Because I know that they're equal. I know that the length is equal to twice the width. And then I still have the width. So simplifying the right side, W times W is going to be W squared. So I get 18 equals 2W squared. Divide by 2. So I get 9 equals W squared. Take the square root, and I get W equals 3. Now the question says find the dimensions. So in this case, I know that the width is 3 inches. I'm also asked to find the length. The length is the other dimension. Now remember that the length is twice the width, so the length is going to be 6 inches. So that's your final answer. The width is 3 and the length is 6. Example 4, you're going to do on your own. So right now, pause the video and try example 4 on your own, please. Play the video again once you have a completed answer. Good luck. Okay, let's see how we did. So it says find the area of a square with a perimeter of 70. So drawing myself a picture again. This is a square, so I know all my sides are the same. And I know that the perimeter is 70. I have to find the area. Well, I know that the area of a square is take one side and square it, because all the sides are the same. So in order to find the area, I need to know one of the sides. So I need to somehow use this perimeter to find one of the sides. Well, I don't know what any side is, so I'm going to call one side S. They're all congruent, so that means all my sides are S. Now to find the perimeter of a square, we add up the sides. So I have one side, I'm going to add a second side, I'm going to add all 4 of those sides and set it equal to 70. So I get 4S equals 70. If I divide by 4, I get S equals 17.5. So each side is 17.5. Now I can find the area. The area is base times height, or just take one of those sides and square them. So I'm going to have 17.5 squared. My area ends up being 306.5 0.25 inches squared. Because remember that area is always units squared. So hopefully you got that right. If not, that's okay. You're going to have more practice tomorrow in class. So that was the first half of the section. The first half of the section was just about those formulas and how to use them. So that should have been mostly review. I bet you've seen most of those formulas before. Second half of the section is about converting units, like converting inches to feet, or yards to feet, or whatever the case may be. So this is going to be something that's pretty confusing, so try to stick with me. Well, let's look at converting units. This graphic here is a way to visualize converting units. So basic unit is going to be your starting unit without any prefixes. So meter is probably the most common one. So you can add on prefixes. You can add on kilometer or millimeter or centimeter, but the basic unit is just a meter. Now, every time that you get away from this basic unit, you're changing by a factor of 10. So one move away is one factor of 10. If I move 2 boxes away, that's 2 factors of 10. If I move 3 boxes away, that's going to be 3 factors of 10. So I'm going to keep that idea in mind as I look at example number 5. So example number 5 asks me to convert from meters squared to kilometers squared. So I'm going to start with 22 meters squared. Now, I need to get rid of the meters and somehow get kilometers in there instead. Because meters is what I don't want, that's going to go in the denominator. Kilometers is what I want, so it's going to go in the numerator. Now I'm going to have to convert twice because I have meters squared. So I have 2 meters, so I'm going to have to convert once for each meter. Now, looking at our graphic above, kilometers is 3 moves away. So it's going to be 3 times bigger. And this is the number that you're going to use. So 1 kilometer will give us 1,000 meters. So that number is always what's going to go in front of the meter. So 1 kilometer, again, is going to give us 1,000 meters. So now, going across, I have 22 meters squared. I have kilometer and kilometer is going to give me kilometers squared. The denominator, I'm going to multiply the 1 by 1,000 and 1,000 again, which will give me 1,000,000 meters squared. Now I have meters squared, numerator, denominator. Those are going to cancel each other out, which is good. That's what we want. 22 divided by 1,000,000 is going to give us 0.000022 kilometers squared. That will be equal to 22 meters squared. Okay, so we got 2 more. I know this is tricky, so stay with me. So the next one, 18 inches squared. So this one is not going to use the above graphic. It's just going to use our knowledge of inches and feet. So I have 18 inches squared. Then I want to convert to feet squared. Now, feet is what I want, so that goes in the numerator. Inches is what I don't want, so that goes in the denominator. Now, I should know that 1 foot corresponds to 12 inches. And again, 1 foot corresponds to 12 inches. I already know that conversion. And now I can multiply across. 18 times 1 times 1 is going to give me 18 inches squared, feet squared. Denominator, I end up with 144 inches squared. Now this is good because those inches squared cancel out. That's what I don't want. I want feet squared. So I have 18 inches squared equals 18 divided by 144 feet squared, which ends up being 0.125 feet squared. So 18 inches squared is the same as 0.125 feet squared. And then we got one more, example number 7. Okay, this one is definitely more difficult. So this time, I'm converting between millimeters and centimeters. Centimeters is what I want, so it goes in the numerator. This should be centimeters squared. Millimeters is what I don't want, so it goes in the denominator. Now I need to figure out the conversion between centimeters and millimeters. So I'm looking at this right here, this part right here. So they are one box apart, so that's going to be a factor of 10. Now I need to think, what is smaller, a millimeter or a centimeter? Well, milli is further away from the basic unit, so it's going to be smaller. That means for every 1 centimeter, I get 10 millimeters, because millimeters are smaller. So every 1 centimeter, I get 10 millimeters. Again, millimeters are smaller. So like that's like this concept over here. Inches are smaller, so I get more inches for every 1 foot. Millimeters are smaller, so I get more millimeters for every 1 centimeter. And now I'm ready to multiply across. So I get 100 millimeters squared centimeters squared over 100 millimeters squared. So those millimeters squareds cancel. 100 divided by 100 is just 1 centimeter squared. So 100 square millimeters are going to give me 1 square centimeter. Okay, so this is something that you'll be doing in chemistry if you haven't already done it. So we'll be seeing this again, and we'll do some more in class if it's a little confusing. But right now, take some time to flip the page, please. Okay, here is your last problem for Chapter 1 in any of the videos. So our objective was to calculate perimeter, circumference, and area of polygons. And we also threw in the converting of units at the end. So here's the problem that you are going to have to do. It says you have a 36-inch by 54-inch picture that is framed with a 4-inch wide frame. Find the area of the picture and the picture frame. Okay, so you need to have 2 answers. You need to have the area of the picture, and you need to have the area of the picture frame. I'm going to help you by setting up the figure. So it says that your picture is 54 inches by 36 inches. And then it says the frame is 4 inches wide. So that means this is 4 inches, this is 4 inches, this is 4 inches, and this is 4 inches. So you're going to have 2 answers. 1, the area of the picture, and 1, the area of the frame. So try your best. When you come to class tomorrow, I'm going to be making sure that you have an answer for this problem and that you have the rest of the work for the rest of the notes. We'll start by going over this problem and then doing a few more examples. If you have any questions, please make sure to star them, bold them, write them down so that you remember to ask me in class tomorrow. And then we will do some more practice. See you tomorrow.